In this lecture, you'll see how to do the initial cluster and SVM peering for SnapMirror and SnapVault with a lab demo using the command line. Let's walk through the scenario first. You can see the lab topology diagram here. Over on the left, I've got cluster 1, which is a 2-node cluster, and on the right, I have got cluster 2, which is a single node cluster. I've already got SVMs set up. On cluster 1, the SVM name is NAS, and on cluster 2, the SVM name is NAS_M, the M for mirror. And in the later lectures, we're going to be replicating data from cluster 1 to cluster 2 between those two SVMs for both SnapMirror and SnapVault. So what we need to do here is to set up the initial cluster and SVM peering. For the networking right now, the NAS SVM on cluster 1 is using the ports E0D and E0E on both nodes, and the NAS_M SVM on cluster 2 is going to be using the ports E0D and E0E also again for the client data access. So for the intercluster traffic for the cluster and SVM peering, I'm going to use port E0F on both clusters. So the networking is already set up for the NAS and NAS_M SVMs. I need to set up the networking for the intercluster traffic. So what I'm going to do is on both clusters, I will configure port E0F as in the intercluster broadcast domain, and then I'm going to configure lifts for intercluster traffic on ports E0F on each of the nodes in both clusters. I also need to add the license for SnapMirror on both sides. So once the licensing is done and the networking is set up, I can then go ahead and do the cluster and also the SVM peering. Okay, so let's have a look in the command line and see what is already set up. On cluster 1 here, I will do a vserver show, and you can see there is my NAS SVM already set up. And if I do a network port broadcast domain show, you can see that there are the ports E0D and E0E on both nodes are set up for the client traffic for the NAS SVM. I've also got broadcast domain set up for my cluster traffic and my management traffic. I'm going to need to configure a broadcast domain for the intercluster traffic. If I do a network interface show, I can see that I've already got my lifts set up for the client access traffic, but I don't have anything set up for the intercluster traffic yet. If we have a look on cluster 2, I'll do a vserver show there. I've got my SVM set up, the NAS_M SVM. That is the SVM that I'm going to be replicating traffic to from cluster 1, and I can do a network, let me try and get that correct, network port broadcast domain show command on here, and I can see I've got my NAS_M broadcast domain set up for the client access and my management and cluster broadcast domain set up. And if I do a network interface show, I can see that I've got network interfaces set up over here on my NAS_M SVM for the client data access again, and also my cluster ports set up there as well. For the intercluster traffic, I've also got a management lift on here too. Okay, so let's go ahead and get everything set up for our cluster and SVM peering then. First thing that I need to do is to license SnapMirror. I'll look in my other window here. I've got this command set up already, so I'm going to copy it from here and enter the license add command, and that is the SnapMirror license for both nodes in my cluster. And there I can see that SnapMirror licenses are successfully added. I need to do that on cluster 2 as well. So I'll go to cluster 2 and license SnapMirror there too. That is done. Okay, so SnapMirror is licensed. Next thing to do is to configure the networking. I'll start off on cluster 1, and looking back quickly at the topology diagram again. So what I'm going to do here is ports E0F on both nodes. I'm going to put them into a broadcast domain that I'm going to call intercluster, and then I'm going to create a subnet for my intercluster lifts, and then I will create my intercluster logical interfaces, configure them with an IP address in the 172.23.7.0 network. So let's do that now. So back in the command line, I will say network port broadcast domain create, and the name of the broadcast domain, I will call this intercluster. I'm going to set the MTU to 1500, and the ports that I want to put in here is on cluster 1-01, the first node, port E0F, and I also need to do cluster 1-02, port E0F. Okay, so that is my broadcast domain created. Let's just verify that with a network port broadcast domain show. And I can see there is my intercluster broadcast domain has been configured. Next up, I'm going to create a subnet just to make it easier to assign the IP addresses to my logical interfaces. So I'll say network subnet create, and this is in IP space default, and the subnet name, I'll also name this intercluster, and the broadcast domain this is going in is the intercluster broadcast domain. The subnet, so the IP address range is going to be in the 172.23.7.0/255 network. The default gateway, the router, is at 172.23.7.254, and the IP ranges that I want to use to assign IP addresses to my logical interfaces, which use 172.23.7.21 to 172.23.7.28. I'm going to configure a range of 8 IP addresses here because I'm thinking that my cluster might grow up to a size of up to 8 nodes. And I have entered a typo there, which is, of course, it should not be /255. This is a /24 subnet. Okay, so that is my subnet done. I can now do a network subnet show, and I can see that there is my intercluster subnet configured. Okay, so that's good. So next up, I'm going to create the actual logical interface to be used for the intercluster traffic. So for that, it is network interface create, and the vServer, this is not for a particular data SVM. This is being used at the cluster level for intercluster traffic. So the vServer I use is the cluster name, which is cluster 1. Then the logical interface, I will name this intercluster_lif1. I'm going to need to create 2 of these, 1 on each node. And then the role here is for intercluster traffic, not data traffic. The home node that I will put this first one on is cluster 1-01, the first node. The home port that this is going on is port E0F for my intercluster traffic, and I'm going to assign an IP address from the subnet intercluster. Okay, that is done. The warning message is just about failover. I don't want it to fail over because I need to have a intercluster logical interface on the particular node. That's fine. I'm also going to have another one in the second node as well. So let's do that now. So I'll hit the up arrow and I'm going to edit this. I'll scroll back. This one is going to be intercluster lif2, and the home node is going to be node 2. And everything else looks okay there, so I can hit enter. and then I'll just do a network interface show to verify that they were created okay. And there I can see intercluster left 1 with IP address 172.23.7.21 and intercluster left 2 with IP address 172.23.7.22. Okay, so those are my networking settings done on node 1. And you saw when we looked at the network topology diagram that for this scenario, I'm using a dedicated physical port for my intercluster traffic. Another option you have is if you didn't have a spare physical port available, then your intercluster lifts can share the same underlying physical ports as your normal lifts that are being used for your client data access. If you do that, then it's a good idea to throttle the intercluster traffic, because when replication is taking place, you don't want that replication traffic to be taking up all the bandwidth on those underlying physical ports, because if that happened, then you would have a performance hit for your normal client data traffic. So to prevent that from happening, if you are sharing underlying physical ports, what you can do is you can limit the amount of bandwidth that is available for your intercluster traffic. So for our scenario, we wouldn't have to do that because we've got dedicated ports. But let's just imagine that we are sharing an underlying physical port with our normal lifts. So I will show you how to do the throttling. So what to do is to enable the option. So I say options, and then the option dash name is replication.throttle.enable and then on. So that turns it on, but I'm not actually doing any throttling yet. I need to specify the bandwidth that I'm going to throttle to. So for that, I say options, and then the option dash name is replication.throttle.max_KBS. So you enter a value in kilobits per second. I'll say 12500, which equals 100 megabits per second. Okay, so that is all my networking settings done now on cluster 1. Next up, we need to do that on cluster 2. So let's just have a look at the diagram again quickly. And I'm going to be doing really very similar settings. I'm using port E0F again on cluster 2 as well. So I need to configure the broadcast domain for it, then configure the intercluster subnet, and then configure the intercluster lift. I'll also configure the throttling on this side as well. So let's jump on to cluster 2, and I will do a network port broadcast domain create. The broadcast domain, I'm going to name it intercluster again. The MTU I will set to 1500, and the ports that are being added here are on cluster 2-01, and it's port E0F. So it's my broadcast domain done. Let's verify it with the network port broadcast domain show, and there I can see that it has been added. Then I need to create my subnet. So I'll say network subnet create. The IP space is default, and the subnet name, I'll call this intercluster again. The broadcast domain that this is in is also intercluster. The subnet is 172.23.9.0/24, and the gateway is at 172.23.9.254, and the IP ranges, IP addresses that I want to give out are 172.23.9.21 to 172.23.9.28. Okay, so that's my subnet done. I'll verify it with a network subnet show. and that all looks good. Next up, I'm ready to create my network interface. So I say network interface create. The vServer is the entire cluster, so cluster 2. The logical interface, I will name this intercluster underscore left1. The role is intercluster, and the home node is going to be cluster 2-01. The home port is E0F, and the subnet name that I'm going to allocate the IP address from is intercluster. Okay, and I can now do a network interface show, and I can see there is my intercluster left with IP address 172.23.9.21. So right now I've got SnapMirror licensed, and I've configured my networking by configuring the broadcast domain, the subnet, and the logical interface for intercluster. I need to have an intercluster left on all of the nodes in both clusters, and I need to have a full mesh of connectivity between them as well. So let's check that now by pinging over to the intercluster lifts on cluster 1 from the intercluster lifts on cluster 2. So I will say ping and then check the syntax. So the lift, this is the source lift, and the lift over here was named intercluster underscore lift1. And the destination that I'm going to ping over to, over on the other side, the first lift was at 172.23.7.21. And I forgot to enter the vServer, so let's just scroll back here, and the vServer I'm pinging from is cluster 2. Try that again, and there we go. I can see that from my intercluster left on cluster 2, I do have connectivity to the first intercluster left on cluster 1. I'll hit the up arrow and check to the other IP address, which is .22 on the other side, and that is alive as well. So I've got my lift set up, and I've got full mesh connectivity between the intercluster lifts on both clusters. Oh, I said I was going to also do the throttling for the bandwidth over here as well. So let's go ahead and do that. So I will say options dash option dash name, and the option is replication dot throttle dot enable dot on to turn it on, and then another typo, I need a space between enable and on, and then I need to set the actual bandwidth that is going to be available. So here the option name is replication dot throttle dot outgoing dot max underscore KBS, and I'll set it to 12,500 for 100 megabits per second over here too. Okay, so that is the networking all set up and configured and verified as working. So all I've got left to do now is to actually do the peering between the clusters and the SVMs. We need to do the cluster peering first. So over here on cluster 2, the command is cluster peer create. And then I need to specify the peer addresses on the other side that I'm going to be peering with. The intercluster lifts on cluster 1 were at 172.23.7.21, and then a comma and 172.23.7.22. And for security, it's going to ask me to enter a passphrase here. I need to enter the same passphrase on the other side as well. So I will enter a passphrase over here and then confirm it. I'm using FLACKBOX'S with a capital F, and it tells me that I can now go ahead and do the same thing on the other side. So I will go over to cluster 1, and over here it's the same command again, cluster peer create, and the peer address, the intercluster left on cluster 2 is at 172.23.9.21. And enter the passphrase, the same as I entered on the other side. and verify it and try to do it without a typo. So I'll enter that again. It's quite hard to type this in and talk at the same time without making a typo. I think I got it that time. Okay, there we go. So now I can do a cluster peer show, and I can see that everything looks okay there. And I'll also do a cluster peer health show, and everything is good. The health is true and the availability is true. So that all looks good. So I've got my cluster peering set up now. Last thing that I need to do is to configure the SVM peering between the two SVMs. So the command for that is vserver peer create, and the vserver that I'm doing this from, I'm on cluster 1 here. So on cluster 1, the vserver is NAS. The peer vserver over on cluster 2 is named NAS_M, and the peer cluster on the other side is named cluster 2. And then the application that this is going to be for is for SnapMirror. SnapMirror covers me for both SnapMirror and also SnapVault as well. I can now go over onto cluster 2, and on this side I'll do a vserver peer show, and I can see there is the request from cluster 1, and it is currently pending, and it is for vserver NAS_M on this cluster. The SVM on the other side is named NAS. So I will accept that now with the command vserver peer accept. The vserver is NAS_M, and the peer vserver is NAS. Hit enter, and I can see this should be good. And I'll do a vserver peer show, and let's just hit the up arrow, and there we go. It just took a second, so it was pending at first. Just took a second. I can see it is now peered, so that all looks good. Thanks for watching. If you want to get hands-on practice with NetApp storage for free on your laptop, then you can download my free ebook, which you can see above my head right now. Also, check out my NetApp Storage Complete course, which will teach you everything you could possibly want to know about ONTAP. Thanks.